Next, we will start routing our traces. As you can see, we already placed our components such that the air wires are more or less aligned, and it should be fairly easy to route them to each other. So where do we start? Well, best is to start with power grounds and important analog signals. We don't have any important analog signals on this case here, so let's start with power and ground. Don't worry about all the designators that are all over the place. We will take care of them later on when we are actually at the end of moving all our components around and started our layout. So first, let's start with powering our microcontroller. We know that power comes from this pin here. This is our programming interface, and as you can see, there is a little air wire going right to VCC. Now, we could route this directly straight over here and then out to our bypass capacitors, but that would make the bypass capacitors ineffective. So what we want to do is route a trace around here through these two capacitors into our pin. We can do that by either hitting the button up here or by hitting P and then T for interactive routing. If you click on your trace, you can see that as soon as you move the mouse, you get a red line, which means that this is copper on the top layer. You can also see that the trace is fairly thin, so hitting the Tab key, you can change the width of your trace. Since this is a power pin, let's just make it large, let's say 20 mils. Now, it tells us that this is outside of our edit rules, so rules that are checking our board, and we can just click here on edit width rules that say we have a minimum width of 8 mil, preferred 8, and a maximum of 8. Maximum we can go here to significantly larger. Preferred, well, in this particular board we are not very dense, so let's say preferred we want a large 15, or let's say a large 12 mil trace, and minimum we don't really want to go below 8 mil, or else manufacturing might become difficult. Having changed that, there is no problem here anymore. You can click on OK, and now you can see that the trace became a lot larger, which means that it can carry a lot more current. It has a lower resistance itself. By moving around, you can see that the routing tries to make different traces, and by hitting space again, you can see how the trace can change its connection style. In this case, we want to go down here into this, and connect over here. As you can see, this trace now is too large. It's slightly bigger than the pad itself, and we don't really want that. So let's make this smaller, 15 mils, and we can see that this connection works really nicely. All right, next step, we want to connect power to these pins over here, because these are the resistors that power the LEDs. Now, we can go and make a trace from here right over through these resistors, but the problem is these LEDs will draw a significant amount of power. What that means is, as soon as they are turned on, they start drawing power, the voltage will drop over here because there is absolutely no capacitor having any kind of charge in it. So it will draw it from over here, there is inductance, and thus the voltage will actually drop. So we have to change our schematics and add a capacitor into here that will help these LEDs to not pull down the voltage too low to actually turn off our microcontroller. So let's go back into our schematics. We place a part. We choose from our library a 1 microfarad capacitor. Place it over here. Let's connect it to this line, and let's add a ground to it. We save this, we go back into our project, and you can see the part has not been added, but what we can do is we can go through design, import changes from the project, and here now found that there was a capacitor added. See question mark. That's not good. Let's go back into our schematics, annotate the schematic. If you see when you click update, the only thing that will change is that one part that had a question mark in it. We'll accept it, validate, execute, close everything, and now it has actually a part number. Again, we save this, go back into our PCB, design, import changes, Now you can see it wants to import C3 connected to ground and VCC. It wants to add the room back into it that we deleted before, so we can actually not do that and don't have that problem. Validate, execute it, and here is our capacitor that we can now simply add over here on the side. Next, PT, we can run our trace. Let's verify that this is a large 20 mil trace. We go out here to the edge, connect all these capacitors, all these resistors, and are done. Next, ground. Well, we could start connecting all the different grounds, and that might not be too bad of an idea, but at the end what we want to do is we want to add a layer at the bottom that's a polygon pore that's all ground. So we will wait with the ground layers itself because that will change later on, but let's keep going with all the different connections that we have on the board. And if you notice, I make a connection by clicking left. I can go route it to the trace. In this case, this was actually wrong. I want these to be 50 mil traces. So again, PT, and have this connected. And finishing up your trace is just clicking right. What this means is that your current trace is done, but you didn't leave the routing mode, so you can still keep going and routing the rest of your traces. So I click left, connect it to my port, and I click right so that the routing is done. Also be careful when you actually route into your your pad here. Don't make a connection like this. This is unclean. You really want to be as neat as possible in your designs. So try to connect this right straight into your pads. This way the signals will be better, and overall the design is just a lot cleaner. Okay, now we can see we have one problem. We can route from pads that are down here up to over here. First of all, let's see what this pad is here. Pin 1 of P2 is P11. This doesn't exist. It's because it's P10. So we found a mistake. Let's save it in the schematic. We go back here, design, import changes. It found the difference. We don't want to add the room again, so all we want to do is add this connection over here that's now there. So trying to make a connection from here to here is not possible through the top layer because we would have to cross one of these lines here. So what we have to do is we have to actually go to the lower layer, move over, come and connect it to there. So what we do is we do PT, zoom in a little bit here. So we route this out, and then I hit the star key on your keyboard. You get a big hole, and now if you move on, you can see that the trace is now blue, which means that we are on the bottom layer. And since these are all pins that are connected at the top and the bottom, this will actually work. And we can do this for all these different pads here. Now, as you can see, I will very quickly run out of space because these holes are so big. So what we actually want to do is this via is significantly too large. So we can scale this down by a lot. So we can go here to 15 mil, and we can say a diameter of 35 mils. So I added 20 mils, 10 mils on both sides. That should be enough. And that way, the hole itself will be significantly smaller. Now, we still need to do 1, 2, 3, 4, 5 different connections, which should be possible. We can, for example, by hitting Control and grabbing this line here, we can move this line over. It will give us space to route out and do traces over here. Again, I hit Control and start moving this particular line here. It will give us even more space. The one thing that happened is that it made an almost right angle up here, which is not really necessary and not really wanted. in your traces. So again, we see if there is still an edge, and in this case there is no edge anymore. So let's select one of the traces and move it over, and you can see that the edge appears again. Now we have 45 degrees angles, which is all right. Again, we can move this slightly further, and now we can route the rest of the signals out. As you can notice here at the bottom, here at the bottom we are still on the bottom layer because that's where we placed the last trace. So let's switch back to the top layer, PT, and now it latches actually onto that signal. Let's move over here. I want to place again a large via, hole size 15, 35, and this is actually outside of the via rules, so let's go in here. Minimum hole size, let's change this to fixed 15, maximum preferred 25, minimum 35. These are the measurements that we actually just added, so we won't have any constraint problems itself. And we go down here, connect it, switch back up. Using the star key while you're not in routing will also switch you back to the other layer. It basically toggles between the two layers. So here in this case, let's go up here, go to the lower layer. As you can see here, this will start to become complicated. We will clean this up in a second because this won't work very well. And where does this one go? We are not using P3, P1.3. We forgot it in our design. All right, in that case, we don't really need to route this one out. Control Z. Oops, that was too much. We want to redo at least some of it. As we notice here, we have a mistake on here. We have a P1.8, which doesn't exist. So let's move P17 one up, and let's just add another ground. Oops. Another ground to the bottom. Again, design import. We don't want to add this. Execute. As you can see now, we have a mistake over here. So that's fairly easy. We just delete this part and we replace it again. As you can see, sometimes it might be difficult on how to route certain signals out. So now we have the two programming signals that need to go from down here to up here. And this signal here is really in the way of everything. So let's remove this signal because these other two signals are actually fairly important signals. This way we can simply take them, move them right up, and again we get a cross in here. So in this particular case, it's probably easier if we just go over here to these two signals and we just switch them around. We save it. This is not always possible. Sometimes a header, for example, is pretty fine, but in this case we will connect to these headers with wires so we can really do what we want and switch them around. We import them again. Remember to remove the room, and now the routing should be simple. We go from this guy here Now we are still stuck with our LED. So if we think about this for a second, how do we get from here to up there? On the top we can't go through, on the bottom we can't go through here, but if we actually get over here we can do it. And that shouldn't be too hard. We can just move this line up. We now move with this trace down here. All right, next step is to connect all these different grounds together. And the way we do this is we go onto the bottom layer, and we now use a tool called a polygon pour or polygon plane. When we click that, we want a solid copper pour. We want to connect this to the ground layer. And this is an important one when we can play with this. And what we want is we want to pour over same net polygons. And we want to pour over all same net objects. Once you click OK, you can actually draw a polygon as large as your PCB. And what it will be is this will be one solid copper pour at the bottom layer that's all connected to ground. And will be connected to these particular devices. So you can see that with these, what's called a thermal relief, it's connected to this particular ground pin. And now we need to go to the top pour, PT again. We want to route from this one here out and go into the ground layer. As you can see, this made a full connection into that plane itself. So it's connected to ground now. Same with this one here. We want to go out and down to ground. Two more connections. Out, down, and one more out and down to ground. And as you can see now, there are no more other connections. What we quickly want to check is that there are no floating wires. That would be bad. Some of these pins that come out here or this are not really fully nicely connected, but that's all right. For this board, this should be okay. And our board is done.